I think we're going to get started already. Thank you, everyone, for attending. My name is Victor. I'm a software engineer at Microsoft. I've been working in the Microsoft SwiftKey Android application for more than 4 years now, and in Android for 6 years. And today we're going to talk about how we use AI in our application. The agenda for today, we'll start with a brief introduction about what we do and why this topic is important to us. Then we are going to look into the two main options that we are going to consider for building AI features, either having them on the cloud or having them on device. Then after that, we'll get into more details about the options we have when having them on device. And finally, we'll hopefully have time for some questions. As I mentioned, I'm a software engineer at Microsoft. Microsoft is one of the biggest companies building and publishing Android apps, with more than 100 apps in Google Play and more than 3,000 engineers working on Android. And Microsoft SwiftKey Keyboard is one of those applications. For those who are not familiar with Microsoft SwiftKey, it is a keyboard application that you can use to type by tapping in the keys of a keyboard layout or by sliding your finger over them, and it will give you corrections and predictions as you go. And it can do this in 700 languages, and up to 5 of them at the same time. It's available for both iOS and Android, but here at DroidCon, for the Android users, it's available on Google Play, where it has more than 1 billion downloads. The team working on this is a team of around 12 people, most of them based in London, with some people now also in Madrid and Cairo. And one thing that is very important to us as we evolve the product is to always keep the application size as small as possible. Our current numbers here are around 20 megabytes of download size and around 55 megabytes of install size. And this is very important to us because it directly impacts installs and retention, but also because it's the right thing to do for the user, try to be as respectful as possible with their device storage. And it's very important for partnerships with device manufacturers. When they are discussing to install your application in their device, if you have a big application, those discussions are going to be more difficult. And with this new wave of AI, Microsoft has been investing a lot on AI. And SwiftKey has been building more and more AI features. SwiftKey has been doing AI for many years, but in the past few years, we've been building more and more new features. And we've been finding similar challenges when building these new features, and we are trying to compile them here in this presentation and share them with you. When we talk about AI feature, what we basically mean is a feature that is somehow powered by a machine learning model. And in more detail, this is going to mean that you're going to have one model or multiple models. You're going to have a model runtime or engine to run that model, and any other data or code that you need to run your feature. And the title of the talk says big AI models. Defining what big means is a good question. The answer is it depends. In this talk, we are going to be talking about models that go from 2 megabytes to 100 gigabytes. But as an example, if someone is asking SwiftKey to build a feature where we need to put a 10 megabyte model in the application, we already have to need some careful consideration, because for us, 10 megabytes is half of our download size, and we're going to start to need, thinking about, do we put it in the cloud? Do we put it on device? If we put it on device, do we put it as part of the main app? Do we download it at runtime? Things like that. So we are going to be looking at the cloud approach, the on-device approach. There is, of course, something in the middle where you can have a hybrid in which you use both, but we are not going to talk about that today. And the idea here is to share some of the aspects that we consider when making the decision between one or the other. So now let's look at the two options. As mentioned, there is no good or bad. It will depend on your needs. First of all, cloud. This is the most straightforward for the clients. All the complexity, all the AI feature is in a backend somewhere, and we don't need to know any of the details about it. The client is just going to get some data, send a network request to the server. The server is going to be running all these models, generating a result, and returning that to the client. Some of the advantages of this approach is that you are going to be running in the cloud. You are going to have more machines available, dedicated hardware, much more power. You're going to be able to run super powerful models. Another advantage is that you're not going to impact your application size. All the complex bits of your feature are going to be in the cloud. So your app is just going to be doing network requests, and all the heavy parts are not going to impact your app. Another good thing about the cloud approach is the flexibility. As long as you keep the communication protocol between the client and the server the same, you're going to be able to change the underlying model. You are going to be able to deploy new updates. You're going to be able to roll out and roll back very easily. But not all the things are good with this approach. Some things that start to get more complicated are privacy. You are going to have some data that is going to leave the device and is going to go to a server. You are going to need to think what this data is. Does it contain any personal information? You need to think if it's going to be stored, for how long is it going to be stored, who is going to have access to it. Is there a mechanism for the user to request the deletion of this data or to request access to this data? It is not something that makes cloud AI features impossible, but it's definitely something that is going to make it more complicated, and you're going to need to do a lot of work and due diligence to do this right. Another big disadvantage is the cost. Every time your client uses this feature or runs these models, you are going to need to call the server, and the server is then going to need to use this machine to run the models, and that's going to cost you some money. If you're using big models, this can get quite expensive, and if your feature is used by a lot of users and they use it a lot, the bill can get pretty high pretty quickly, and it might not be worth for you paying for it. So you have to be careful and take always the cost into consideration for this thing. And the last one, it may sound obvious, but you are going to need an internet connection for the feature to work. There might be some features that just because of the reason, they cannot really utilize the cloud approach. And you also have to deal with poor connectivity scenarios in which you may have a degraded experience for the feature. We found that this approach is suitable for when you have a model that is so big that really you cannot run it on device or you cannot run it efficiently. You are just going to have to go for the cloud. You don't have much of an option there. But it works very well when your feature is not very frequently used. This is for cost reasons. You can make it work for a frequently used feature, but it's going to be more difficult. And also, we think it works better when there is some latency that is acceptable. So this means even though we are using bigger machines and dedicated hardware and whatever, we are going to probably be running bigger models that are going to take a bit longer. And we also have a network overhead to account for. And this may make this option not possible for certain features. And let's see some examples of AI features that use the cloud in SwiftKey. So first, we have our sticker generation feature. You just type the description of a sticker, submit it, wait for a few seconds, and eventually, you'll get some sticker results based on what you typed. You can then share these results with your chat application, save them for later, do whatever you want with them. What is happening under the hood, when you tap on the submit button, we are sending this sticker description to a service which is using the DALL-E 3 model to generate the stickers and give them to the client. Comparing this to some of the aspects we were mentioning before, DALL-E 3 is really a model that we cannot run on device, so there is not much of a choice. But there are a couple of other aspects that make this feature possible and sustainable for us. For example, the usage. Users use the keyboard to type. Only some users will send the stickers, and they will do that every now and then. So that makes the cost manageable. We can afford to pay for the bill for this feature. And some latency is expected. We already have some features in the keyboard and in Android in which you type a query, you submit it, and then you're going to have to wait a few seconds before you get the results. So that doesn't ruin the experience for the user. A couple more examples of cloud feature is the designer feature, the one in the left. It's the same as the sticker generation feature, but for images in general format, not the sticker format. It's using DALL-E 3 as well to generate the results. And on the right side, we have the tone change feature, where you give it some text, and it will rewrite it using different tones, like witty, polite, funny. What is happening underneath is that we are sending this text to a service, and the service is ultimately using a large language model to generate the results and return them to the client. That's for the cloud. Now, let's look at the on-device approach. This is the most complicated option for the clients. We need to get a model or a collection of models. We need to get a model runtime and any other app or data to the device and make it accessible to our app for it to run locally. And what were advantages of the cloud approach are now disadvantages, and vice versa. So one of the main benefits of this is the cost. Now, every time you run your feature, run your models, you are not going to have to pay for it. You may need to pay for the cost of downloading some models, and you also need to be mindful that you are using user resources, you are consuming their battery, but this makes this approach very cost-effective. The second benefit is the availability. Everything runs locally, therefore you don't need an internet connection. Your user can be in the mountains, in the tube, here at Droidcon. The features should work the same all the time. Privacy is also a big one here. If you do things right, data should never be leaving the device, and therefore the privacy implications are much easier to manage. And these three can be pretty big aspects to consider when making a decision. Some things that start to get a bit more complicated with on-device is model updates. It will depend on the implementation, and we're going to look into them later. But you can have options that are close to be as flexible as the cloud, but also options that will require you to update the app every time you want to update a model. And these other disadvantages are you are going to have limited size and limited computing power now. You are running on a device, and therefore you need to build a model that is smaller, that is faster, optimized for mobile. And you also need to take into account the fragmentation of Android. You may have a very modern high-end device that can run your model seamlessly, but then you may also support a 10-year-old low-end device that is going to struggle doing that. And finally, what we were mentioning before, application size. One way or the other, we are going to be impacting application size. Is it going to be download size, install size, or storage space on the device? It depends on the solution, but there is going to be impact somehow, which we didn't have with the cloud approach. And we think this is suitable when you can do it. You have a model that is small, can perform well on device, and can actually power your features, but also works very well when your feature is used very frequently, because there is no cost associated now with running your feature or your models. You can run it very, very much all the time. And when performance is important as well, we are going to have less powerful machines, our devices, to run it, but we don't have the network overhead, and we are probably going to have faster, more optimized models. So that allows some features to get responses in very low latencies. And a very good example of on-device feature for SwiftKey is the typing experience. We don't want to pay every time you tap on a key. We don't want to be sending your character to the cloud every time you tap on a key. And there are other things like the app size impact that we'll talk about later. So just as a summary, putting both options side to side with the different aspects, one of the first things to think about is feasibility. Do you have a model that you can run on device, that you can fit on device, and that you can actually, with all the devices that you support, use? If the answer is no, then you don't have much of a choice. You have to go with the cloud. But if the answer is yes, then you can start looking into the rest of the aspects. And depending on your feature, some of these aspects are going to be more important. Privacy costs are usually very, very important, but it will depend on the use case. But let's look a little bit more into the on-device part. Cloud is, for app developers, for us, is very straightforward. But on device, there are many ways you can go about it, and we're going to see a few of these. The main question here is we need some models, we need some model runtimes, we need to get them to the device, and we need our app to use them to run locally. We're going to be using device storage. You're going to be using the resources of the device. But the main question that we have to solve here is how do we get all these AI features to the device? We're going to be looking at similar aspects as we were looking when comparing cloud versus on-device. But there are a couple of them that will remain the same, like privacy and latency. But there are other things like download cost, support for updates, application size impact, that we are going to be looking into more detail now. The first of the options, well, maybe you don't even need to build anything. Maybe the operating system, the system APIs already have something that you can leverage. For example, Android recently introduced AI core APIs that you can use to run Gemini Nano in some of the most modern Android devices. The advantage of this approach is that you are not going to need to build any model. You don't pay for any download cost, and you are not going to impact your application size. So this is a very fast and cost-effective approach. The disadvantage is you're not going to have any control over the models, model updates, model availability, and the customization that you'll have is whatever they offer in the APIs or whatever you can do on top of their output. But we have some examples where this works for SwiftKey. And this is our new multimodal voice typing experience. You can alternate seamlessly between dictating and typing with the keyboard layout. And for the dictation part, we are using a speech recognition service, which is a system API, a system service, that gives us the speech recognition part. And this is implemented by a system app or a third-party app, and we can just call the system API and leverage it to build our feature. We don't need to build the model. We don't need to pay for the cost of downloading that model, but we are a little bit limited in terms of what we can customize. But if it works for us, it is a good option. This is not strictly on-device. The implementation of the speech recognition service can go to the cloud, but it's a good example of how you can leverage some system APIs sometimes. But if you really need to go and build your model, well, you can start very simple. Can you put it as part of your main app? There are going to be some clear advantages of this. First, you're not going to pay for the download cost. It is going to be the application store. Second, it is going to be available all the time. You download it when the app is first downloaded or installed. Disadvantages, you are going to impact your download size, which is not great. You are going to impact all your users as well, even if they don't use the feature. And finally, you are going to be very constrained about model updates. If you need to update your model, you're going to need to update your app. And some cases in which we think it can work, if you have a quick prototype to build, this can be a very fast way to get it up and running. If you have a feature that all your users use, or most of your users use, maybe this is an option. And if the size is something you can afford, you can go for it. We don't completely leverage this one on SwiftKey, but we partially use it. And let me explain that. We were mentioning that we have models, and then we have model runtimes that we need to run our AI features on device. We know for SwiftKey, users are going to at least use one model or a few models. So they are going to need the runtimes at some point. And the size of the runtime is something that is manageable for us. It's something that we can put as part of the main application size. And therefore, we ship the runtimes as part of the main app. And this simplifies a lot, integrating new AI features for us. But let's say putting it in the main app doesn't make it for you. Well, you can start looking at another options, like using on-demand delivery. This is supported by some application stores, and you can have part of your application that you don't deliver when you deliver your main app, and you can choose when and how to deliver it. And the advantage of this is that it is still the application store that is paying for the cost of delivering your feature and your models. And the second now, compared to the previous one, is that you can now control what users are getting it. So you can save the space for all the users that are not going to really use the feature. Disadvantages are that you now need to manage the availability of the feature because it is downloaded separately from the main app, which adds a bit of complexity. You are still very constrained in terms of updates. You need to update your app every time you need to update your model. And this may not work if your application store doesn't support it. Google Play does. I think Huawei App Gallery does, which are some of the most popular, but maybe you are distributing in a different store and this doesn't work. And we think this works very well, or can work very well for experiments. You have a new feature, and you don't really want to invest a lot on it yet without having any data before to validate that the feature is good. Instead of building your server and getting everything up and running, you can very quickly set up a dynamic feature module, put your models in there, put your feature in there, and deliver the feature only for the users that are part of the experiment. Another use case for this is a feature that is heavy, that only some users are going to use. Instead of just putting it for them and making them take the impact on application size, you can decide that only the users that are going to use it are going to get the impact. And we have some examples of this in SwiftKey. So we have a camera feature. You can take a photo, you can record some video, and then you can apply some filters to it. We know most people use the keyboard to type, and only some of them want to become potatoes or comic book heroes. So, and this is a heavy feature. And the way we manage it is we put it in a dynamic feature module and distribute it on demand only when the user goes to the keyboard entry point for this feature and decides that they want to use it. Another example here is our search intent feature. This is an experimental feature. What we try to do here is, as the user is typing and sending messages, we try to detect when they want to perform a search. And we suggest that in the suggestion bar. This uses a lot of models that are quite heavy. And before building a server to deliver these models, we don't really know if the feature is going to be successful. We don't know if the users want this. So a quick way to run an experiment and get some data before investing more is to put everything in a dynamic feature and deliver this dynamic feature to the users that are going to be part of the experiment. But finally, if none of the previous options work for you, you can go for the most involved of the options and the most expensive, but also the most flexible and the one that scales better, which is you download them at runtime from your own servers. And the advantages of this is that now you don't impact either download size, as we did with putting it in the main app, or install size, as we did with the on-demand dynamic feature. You also are going to have the control about who is getting the model. Only the users that are going to use them are going to get it. And one key advantage of this one that we didn't have with any of the others is that you can build a system to deliver model updates without having to update your app. And this gives you a lot of flexibility and a lot of possibilities in the future. So this makes this option very attractive. But there are some downsides here, which are you're going to, of course, have to pay for the download cost. Every time a user downloads a model or updates a model, that's going to be on you. You're going to have to pay for it. And you're going to have to manage the complexity of your feature is not going to be available until you succeed in downloading the model. And we think this works very well for when you have many, many different models. For example, many models for experimentation or models per language, because it gets easier to manage when you have a system like this in place. And it also works better when you have smaller models, because of cost reasons. But it can work as well with bigger models. You just have to make the numbers and make sure that it's worth for you doing this. And let's look at some examples of when we download the models at runtime in SwiftKey. So the core typing experience. You can type in more than 700 languages in SwiftKey. Each of these languages has a language model, and they go from 2 to 20 megabytes. And we don't want to download 700 languages for every user. So having them download them from a server let us have the granularity to just pick the language that we think the user is going to speak or use to type, and also let the user select the language that they want. And more things that this gives us is the ability for updates. So we can have a 7-year-old version of SwiftKey, very old client, but we have the ability to update the models still via the server without having to update the app. So this allows for this support for all clients as well. And experimentation gets very easy and very quick. We don't need to change anything in the client to just run an experiment on a new language or on an existing language. We just deliver server-side the right model. And a couple more examples of models that we download from the server is the emoji predictions models. We have a couple of emoji prediction features. In the first one is, as you type, you can get emoji predictions on the suggestions bar. And this model is downloaded from the server. And same for the emoji prediction panel. Here, you just have a panel with more emoji results based on what you've typed, and also on emojis that you've used in the past. And on the right side, we have our handwriting feature. There are some languages in which typing is a bit more complicated, and maybe we cannot fit all the characters in the space of the keyboard. And there are other mechanisms like handwriting that are popular. You just draw a character, and we try to match it with the closest character in the language. For example, I think this is the Chinese character from mountain. And this is also a model that we download at runtime. So, to summarize, to wrap up, all the on-device options that we've been considering here. First, it would be the operating system. Is there anything available already that you can use to power your feature? If there is, and it works for you, you are not going to have to pay for any cost. You are not going to have to increase your application size. but you're going to have little control over it. And well, this may work or may not work for you. For us, we saw the multimodal voice typing experience. Then, if this doesn't work, you can go with putting the model as part of the main app. You're not going to have for any cost of downloading, and you're going to have the model available all the time. But you're going to increase the download size. You're going to impact users that don't need the model, and your ability to update the models is very constrained. You need to update the app. And we saw that, well, it can be used for prototypes, but also you may use it partially for things like the model runtimes. Then we have dynamic delivery, on-demand dynamic delivery, similar to the previous one, but with more flexibility. We don't pay for the cost still, but now we control what users get the models and the feature. So that gives us the ability to save space for those that don't need to use it. And the disadvantages are very similar. We are now going to have to manage when the feature is not available. We are not going to have control for updating the model without updating the app either. And we saw the camera and search intent feature from SwiftKey. And finally, the most flexible of the option, most scalable, downloading from the server. We saw the benefit of not impacting the application size, also having the flexibility to support updates without updating the app. But we saw the downside of having to pay for the cost and the complexity of managing this time when you don't have the model available still on client. And we saw the core typing experiences in SwiftKey that leverage this. And I think that's everything I wanted to share today. Here are some resources about things that have been mentioned before. And I would like to use some time for questions. But before we jump into that, I would like to say thank you to the SwiftKey team, because I'm just presenting this, but this is the work of all the team for many, many years. And thank you all for attending. So now, if there are questions, I would love to get some and answer them now. What are your questions? Anyone? How do we store the models? In the application? It's usually just a binary file. It will depend on the model implementation. But yeah, it's custom format, for example, for the models that we use for the typing experience. Can you repeat that? Analyze. Oh, yeah, we have for typing experience, for example, we have our custom runtime. That is the one that is going to get the model and read the model and use it. So everything is custom. I don't have all the details to share because for us, it's like a black box, but we have the files, the model files, and then we have the model runtime. And it is the model that is going to decode that file and use it. Happy to follow up with more details afterwards, if you want.
I want to say something. Yeah, thank you. I have a question as well. It's about the privacy implications of the tools. Some of the tools you have to run on the server side, and it analyzes data that you are entering in your device. So is there some kind of profiling per user that are using these tools? Some data that you guys collect from the users in order to provide better recommendations in the future, something like that?
So the question is about whether we use some of the input from the user to customize the features or personalize them for them?
Yes.
For example, for the sticker generation, tone change, all these features, we don't really collect any of this data. We just use it to generate the results, but we don't use it to customize anything for now. That helps us keep the privacy story simple, but in the future, if we wanted to use the data to customize the feature, we would probably need something something else in the client, maybe some consent, some other things. And we've decided to keep it simple for now. But yeah, if we were to extend the features, we should probably do more work on that.
Okay, thank you.
Is another question?
Thanks for the talk. You mentioned that you can ship models to devices that are really old, so let's say 10 years. Do you do any testing to make sure that models are still performant on device on old, low-spec devices?
Yeah, that's a good question. We do some automated testing. We try to always, so we have some performance testing, and the device that we use a real device. Although now we are also moving to use some emulators. We try to keep it kind of representative of our user base, and we also try to keep it low end. So we have this kind of automated testing that ensures we don't have regressions in all devices. But we also have to do some manual testing when we are trying to keep this model performant in all devices.
Are there any particular tools that are good for doing this testing with AI models?
We are now starting to look into some of the Jetpack benchmark libraries. In the past, what we've had is just custom internal libraries for measuring these things.
Cool, thank you.
Okay, something más related to the code. Do you manage these features on your server, like the dynamic features, different models for each feature?
Yes, good question. We do have part of the control for the dynamic features on the server. So for example, we were talking about the experiments. So let's say we want to run an experiment with 2 different models in our app. One way to do it, you can put them one on each dynamic feature, and then you can talk to the server for a user to get into an experiment, and the server will tell the user, you need to get this dynamic feature module, which will give you this model one. That was your question, right?
Yeah.
Yeah, we combine having dynamic features with some control or knowledge on the server side about these dynamic features as well.
Nice.
Any more questions? There is one here.
So do you have any statistics, like how used are these AI features from the regular users, like a percentage or something like that?
Yes, we do have. I don't know how much I can share. I can tell you, yeah, they are not very popular. We know the users use the keyboard mostly to type, and only a few users will use these features. We do have the data, but I don't want to say anything I shouldn't say. Yeah, they are not very used. Less than 50% of the users are going to use one of these features.
Yeah, thanks.
More questions? One more in there? I don't know if we have time, but happy to keep going.
Do you have some tips for us for making the optimization of the model to implement in the device?
Some tips for implementing the device?
Yes.
The on-device approach? Well, so I was mentioning for the previous question that for the typing experience, we are using custom stuff, but there are a lot of open source things. For example, for some of the most new features, we are using Onyx Runtime and Onyx, which is an open source format and is built by the community. So probably a good idea if you want to get started is to look into some of these open source projects and try to get a project up and running, and then see if you can adopt the model formats and the model runtimes that they provide. I don't have any, I mean, if you have more specific questions, I can maybe provide some other tips.
Thank you.
Anything else? All right, thank you everyone.